This video is on the objective, write a vector in terms of vectors I and j. Okay, so before I get to the question, if you want to see more about the topic, click on More Instruction, look at their videos, their notes, their examples, and hopefully those help you out. I'll show you some of those notes here, right? You'll see some of this in if you click on More Instructions sometimes. Other times I might have this video down here, but so far, right, we have investigated the basics of vectors, right, magnitude and direction, vector addition and subtraction, scalar multiplication, the components of vectors, and the representation of vectors geometrically, right, when you draw them out as pictures of arrows on the xy plane. Now that we are familiar with the general strategies used in working with vectors, we will represent vectors in rectangular coordinates in terms of I and j. Now they do not mention what I and j are here, so I've drawn them out for you. Okay, vector I, right, when they talk about I here, that's just simply the vector with components 1, 0. If you were to write it as a standard vector with the wedge notation like this. And this simply, this vector I simply means a motion of 1 unit to the right. So if I were starting at the origin, the vector I would be the motion, 1 unit right, that arrow there, to the point 1, 0. And the vector j that they're mentioning is simply the vector with components 0, 1. Right, in the wedge notation, the position vector notation. So if I were starting at the origin, this vector j is meaning the motion move up 1 unit. Right? And every vector, say vector with components a and b like this. If you think back to how scalar multiplication and vector addition worked, I could rewrite any vector with components a and b as a times the vector 1, 0, right? If you think of a now as a scalar, plus b times the vector 0, 1. But rather than write all this out, we just replace 1, 0 with I and 0, 1 with vector j. So a times vector I plus b times vector j, right? So it's very easy to go back and forth between vectors in standard notation and vectors with this I and j notation. Right? The coefficient of the I is simply the first component of our vector, and the coefficient of the j is simply the second component of our vector. Alright, so pretty simple stuff. So I'm not going to go into more of the instruction. I'll just get to the question now. We should have enough to be able to answer this the following question. Alright, so say we're given points. C has the coordinates -4, -5. Notice these are parentheses, not wedges, right? This is a point, not a vector. And point D at -1, 1. Express the vector CD, right? So C is the initial point and D is the terminal point, and I'll draw a picture of this in terms of I and J. Alright, so back to my paper. Let's write out this information. So here's the coordinate plane. Again, I'm doing a hand drawing. I'm going to try my best to make it look good. So we're given this point C at coordinates -4, 5. Right, so -4 on the x and -5 on the y. Okay, so here's point C, the initial point of the vector. There's C. Then the terminal point, where we're going to end the motion, end the vector, is at -1, 1. So -1, 1. So here, there's point D. And here's the vector, from C to D, the motion. That arrow there, right? There's vector CD. Okay. Now what we're asked to do is write this in terms of I and j. Now hopefully you recall how to write the components of a vector, from an initial point to a terminal point in standard notation, right, the wedge notation. Remember, for the first component, you take always terminal minus initial. So what's the x-coordinate of the terminal point of D, which would be -1, minus the x-coordinate of the initial point? And then same thing goes for the second component, right? You just subtract the y-coordinates, but in the same order, right? The y-coordinate of the terminal point D minus the y-coordinate of the terminal point C. So that'd be 1 minus -5. So the first component would be +3, meaning right 3 units. And the second component would be +6, meaning up 6. So if I went from C to D, that's going right 3 and up 6. But if you recall, moving to the right is moving some amount of I. If I move right 3, that's 3 of these I's. And if I move up 6, that's 6 of these J's. Right. So this is equivalent to 3 times vector I plus 6 times vector j. And this is what they're asking for right here. So again, these mean the same thing. They're representing the same vector, moving right 3 up 6, but written in different notation. I should have an arrow above the j. That's a vector. Okay. So then back here, so again, they want it in terms of the I and j, and I said it was 3i. Let me move my cursor. 3i plus 6j. And that represents the vector from C to D. Right? Yeah, again, if you know everything about standard notation, changing to this I and j notation should be no problem. And also vice versa. You can go backwards. If you know the IJ notation, you could very easily write the standard wedge notation. Wonderful. Alright, so hopefully watching me do this, looking at the more instruction when you need to, and reading the answer explanations when they come up. Hoping all this stuff helps you when you go about working on this material on your own. And thank you very much for watching.